Welcome to Lesson 8.6, Identify Special Quadrilaterals. So we've already looked at definitions and properties of different quadrilaterals throughout this chapter. Now what we're going to do is use those different properties and definitions to identify special quadrilaterals by their names. So to help us out with that idea, this diagram here is known as a hierarchy of quadrilaterals. So as we move down the diagram, we're getting into more specific shapes, and the properties are building up, meaning we know a quadrilateral simply has four sides. A trapezoid has four sides and opposite sides are parallel. A kite has four sides and consecutive sides are congruent. So as we go down, we're adding more specific properties to each of our figures. So what that means is, for example, any shape on the hierarchy, such as a rectangle, would share the same properties as a parallelogram, as an isosceles trapezoid, as a trapezoid, and a quadrilateral. So any figure has the properties of the shapes that it links to going back up to the top of our hierarchy. A rectangle, though, does not link to a kite, so it would not have the properties of a kite. So another example of that would be a rhombus. A rhombus has the properties of a parallelogram, a kite, a trapezoid, and a quadrilateral. So looking at the hierarchy, that would mean if we're calling a shape a rectangle, that means that shape is also a special type of isosceles trapezoid, a special type of parallelogram, a special type of trapezoid, and a special type of quadrilateral. But we simply then call it a rectangle. So looking at example 1, it says quadrilateral ABCD has at least one pair of opposite angles being congruent. What type of quadrilaterals meet this condition? So what quadrilaterals have one pair of opposite angles being congruent? Well, if we look at our definitions and theorems, we know that a parallelogram, by definition, has opposite angles being congruent. So if it applies to a parallelogram, it would apply to all the things linked below it. So if it applies to a parallelogram, it would apply to a rhombus, it would apply to a square, and a rectangle. But then we also know the other figure that has opposite angles being congruent is a kite. So quadrilateral ABCD could be a parallelogram, a rhombus, a rectangle, a square, or a kite. There's 5 possibilities based on opposite angles being congruent. Example 2. What is the most specific name for quadrilateral here, ABCD? So what they marked were some markings on the diagonals. We don't know anything about angle measures or exterior measures. So when we're choosing our answer, we can only base it on the info that they marked. So I know AE is congruent to EC or CE, and I know BE here is congruent to ED. What that tells me is the diagonals bisect each other. So according to theorem 8.10, if diagonals bisect each other, and we don't know any other info, we can classify that as only a parallelogram. So as we go through these examples, you'll notice that they build back into a lot of the definitions and theorems that we already used. So having your previous lesson notes will be helpful for this lesson. Then we go to example 3. Example 3 asks, is there enough information given in the diagram to show that this quadrilateral, PQRS, is an isosceles trapezoid? Explain. So first we want to prove that PQRS is a trapezoid. Well, what we know is angle R here and S here are supplementary. They add to 180. P and S are not. So what that tells us is PS here and QR are parallel, but PQ is not parallel to SR. So one set of parallel sides, by definition, gives us a trapezoid. So we know PQRS is a trapezoid. Now we need to see, is there enough info to show it's isosceles, meaning it has base angles that are congruent. Well, because we already knew it's a trapezoid, and we knew PS was parallel to QR, P and S make a pair of congruent base angles. So because the base angles are congruent, PQRS is an isosceles trapezoid by definition of, or by theorem 8.15. Now example 4 tells us to give the most specific name of the quadrilateral, explain the reasoning. And again, we can only use markings and measurements provided. You couldn't take your protractor and measure these different angles to try to get more info. So all we know in this case is that side RS is 50, ST is 50, TU is 51, and RU is 51. So what I see is that I have two pairs of consecutive congruent sides. RU and TU are congruent, ST and RS are congruent. So two pairs of consecutive congruent sides would give us a kite. Number 3 here. We know the different diagonal measures. We have 64, 80, 75, and 62. And then we know VW is parallel to YX. So we definitely know one pair of parallel sides, and the diagonals do not bisect each other because we have different measurements there. So one pair of parallel sides, diagonals don't bisect, so it can't be a parallelogram. So that only leaves us with the answer of a trapezoid. And then in 4, they gave us CG congruent to GE and CF on bottom congruent to DF on top. No other info. Well, one set of congruent sides on the outside doesn't help us. One part of congruent diagonals doesn't help us. So all we really know is this is a 4-sided figure. So simply put, we can only name this figure as specific as possible to be a quadrilateral. We don't have enough info to be more specific otherwise. And then we get down to our last example, example 5. So in example 5, it's an error analysis, meaning we're going to find the mistake. So a student knows that the following information about this quadrilateral, MNPQ. They know MN is parallel to PQ. They know MP is congruent to NQ, and angle P is congruent to angle Q. The student concluded that MNPQ is an isosceles trapezoid. Explain why they cannot make that conclusion. So it's actually possible that this is an isosceles trapezoid, but it also is possible that MNPQ could be a rectangle or a square because they don't say anything about the relationship between side MQ and NP. If MQ and NP ended up being congruent, then we could have a square or a rectangle. So without knowing further information, we know that this shape could be an isosceles trapezoid. But if we know more info, we also could know that if we find out more about these two sides, it could be a square or a rectangle too. Until they give us info on these two sides, we can't narrow it down. So the main idea, though, for this lesson goes back to taking all the definitions and properties that we've already used in this chapter and looked at, and using those definitions and properties to identify different special quadrilaterals based on a set of characteristics. And remember to look at the hierarchy. If we have something like a square, then it has the properties of a rhombus, a rectangle, and all the other figures linked above it.